Example 2 is more of the same, just instead of using some numbers, now we're going to use some variables. But all the log laws stay the same. We want to write each expression as a single logarithm. That means you're trying to take everything from the right side of those formulas and change them to the left side, so you get one logarithm in the end. Now, when we look at our log laws, and I'll just go back to the last screen here. When we get to our first question here, we've got log x plus 3 log y. So it's going to trigger some things for you. You'll see the 3 out in front. That should trigger this second one that we wrote here. And the adding should trigger the first one. So the question is, which one do I do first? Yes, exactly. And when we're looking at the adding one thing to look at when you're looking at a formula is what are the aspects of it. We already talked about that the bases have to be the same. The other thing that shows up in this first formula is that there are no numbers. Use a different color. There's no numbers in front. It's just log plus log. It's not log plus 3 log. It's not 2 log plus log. There's no numbers in front. In other words, there's a 1 in front. So we can only use that first log law if it's a log plus a log. And what we have right here is we have a log plus a 3 log. So the first thing, whenever you're combining it as a single logarithm, the first rule you will always do first is your power rule. And your power rule says we can take that 3 that's out in front and move it in as an exponent. Now you have a log plus a log. Both of them have the same base, so we can use the log law, the product law, and put them together. And now it's written as a single logarithm. For part B, again, we'll always do that power law first. So whenever there's a number in front, we'll put that in as the exponent. So here I've got a 2 in front. So that'll become log y squared. And I have that 4 in front. So that'll become log z to the 4. Now we have adding and subtracting. So when wondering about which one you should use first or second, I'm going to tell you it's not going to matter, but I'm also going to tell you that we're going to do this all at once. We're going to find out that whatever's added is multiplied, and whatever's subtracted is divided. And so whatever's multiplied will be in the top part of your fraction. Whatever's subtracted is going to be in the denominator of your fraction. And so we're going to be able to put this together all at once. The x and the y squared are added, so they'll be multiplied together on the top of our fraction. And the z to the 4th is subtracted, so that's going to be on the bottom of our fraction. And for part C, we've got log 2 of 6 minus 3. And that minus 3 is all by itself. This isn't a single logarithm because we've got that extra minus 3. But the only way that we can put logs together is if we have a number multiplied out in front, a log plus a log, or a log minus a log. So in this case, we're going to have to change that 3. And I'm going to show some work off to the side in this red box here. Question is, could you write 3 as a log? And in particular, if we're going to be subtracting 2 logs, it needs to be a log of base 2 so that it matches the base of the other one. So now our question is, could you write 3 as a log with a base 2? Now, what we're missing is a number in here, right? And because you haven't used logs a lot yet, it's pretty natural for that number not to jump out at you and go, oh, I know what it is. So how do we do that? It is going to be 8. If you can't see that it's 8 right away, put an x there. And then use your definition of a logarithm. What does a log mean? What does a log solve for? A log solves for exponents. And if we use our definition of a logarithm, the base is 2. Logs solve for exponents, so the exponent is 3 equals x, and that will tell us that x has to be 8. So we did that work off to the side so that we can now rewrite this. This is log 2 of 6 minus log 2 of 8. Now we're subtracting with the same bases, so we can use the log law that says you can divide, and you get log 2 of 6 over 8. If you wanted to reduce that, so a multiple choice question could say log 2 of 6 minus 3 is equivalent to, and then this would be one of the answers. And you'd have to combine it as a single log to see that it matches. If this was a contest multiple choice question, I probably would make it even more difficult and say log 2 of 6 minus 3 is equivalent to, and the right answer would be log 3 minus 2. Log 2 of 3, sorry, minus 2. Does it make sense that log 2 of 6 minus 3 is equal to log 2 of 3 minus 2? No. How did I get that? I took this and I expanded it. So what's log 2 of 3 divided by 4? Well, it would be log 2 of 3 minus log 2 of 4. Does that make sense using the log law for when you divide, you subtract? And then log 2 of 4, 2 to what power is 4? 2 to the power 2 is 4, so log 2 of 4 is equal to 2. So it's just kind of a weird looking thing to say log 2 of 6 minus 3 is equal to log 2 of 3 minus 2. No, in the afternoon. Okay, so the questions for this one, and we'll take some time to do the ones from question 1 and question 2, are 5, 8, 11, and 18.